Hello, my name is Lukas Oldenburg, and today we're going to take a look at how to install the Stream Firestore to BigQuery extension. And this extension gives you your Firestore data in BigQuery, so you can analyze it, build reports based on top of it, etc. Make sure you read the accompanying article for that to get a little bit more context. But now let's get started. So first of all, you need a Firebase project, and I assume for this guy that you have already created a Firebase project. It's really easy. Just go to Firebase and then click create a new project, link it with your Google Cloud project, etc. And then you go to the Firebase extensions hub, and there you'll find a Stream Firestore to BigQuery extension. And now let's get started. So we'll install that in our Firebase console. And I choose my project. So I'm going to use a project of the component manager. It's an application for Adobe Analytics admins to make their Adobe Analytics admin work a lot more efficient. So here we're at the first step. We'll click next. We'll accept that will be built for that, but the price of course depends on how many changes you do to these Firestore documents. So if you have a Firestore database where every second or so a document is updated, every change will trigger a streaming export. So you definitely don't want to use this extension if you have such a high volume of document changes. In my case, the documents are created once and then updated once usually, and it's not that much going on outside of that in these documents. So that's a better use case for this extension. But before creating this extension, of course, make sure that your Firestore database that you want to use it for is actually suitable for this type of extension, because every change to the document triggers a BigQuery export, and that not only makes your BigQuery table huge, very fast, because it will just insert a new row with a new timestamp, and then you'll just query the newest timestamp for a row in BigQuery. It's also, of course, every run generates cost resources because the cloud functions run in the background, etc., etc. So yes, we're fine enabling the BigQuery API, the Cloud Tasks API, and the Event Arc API. And it will create these cloud functions. So don't worry, don't wonder why there are suddenly these cloud functions after you've done this. And we click next. And yes, we'll also say yes to the access granted to this extension. Finally, we select the location and so on, and make sure that it's running in the same location as your Firestore database. Project ID still the same, and now we have to do a little bit more work here. So the dataset ID, of course, is going to be the BigQuery dataset ID where you want to hold all that stuff. And I'm going to name this script monitoring, and the table ID I'll call script runs, and that's a table ID prefix. It's not the actual table ID. So in BigQuery, I will later then have a table, a data set called script monitoring, and a table called script runs, and then we have raw changelog and raw latest. And I created a third table, a second view. Sorry, this is a table. These are views, of course, and I created a second view called latest flat to have it in a flat format that's easy for Looker Studio reports then. But we'll hopefully get to that. So we have the script runs table ID, and then the BigQuery SQL table time partitioning option type. And we want to partition this by day. And the partitioning column name is going to be started, because I'll want the script runs to be partitioned by the time the Firestore database entry was created. So we see here we have a field called started. It's the Firestore timestamp data type, and we'll create a copy of that in BigQuery to have it on the top level as well for querying. If that works, in my earlier tests it didn't work. That's possibly a bug in this extension, but let's try again. So the Firestore document field name for BigQuery SQL time partitioning field option. So this is basically the source for this field. if I don't understand it wrongly. And as I've just shown, this field is called started. It has to be a top level field, and we see this is on the top level. If it's not on the top level, you will see some nesting here. This document is all flat, so here we have an example for a nested field, just with some objects inside. Okay, we go back to the install guide or install window. Time partitioning table schema. It's supposed to be a timestamp because this source is also a timestamp. So we'll see here, this is the field that is ultimately getting created, started, and the type is a timestamp. All right, then we have the BigQuery SQL table clustering, and for this we'd have to dive deeper into table clustering, but in short, if you use a couple of columns very often for queries, it makes sense to name them here. I'll leave this out. Just don't enter anything, and then it, I think, stays empty. Maximum number of synced documents per second. Yeah, I'm not going to have more than 10 per second, hopefully. And even if then that happens, then it's not that terrible if I miss one of those. In this case, it's not a super important case. But if you have a lot of syncs, then you can raise this. Backup collection name, I'll also not use that. Then the transform function URL, so you can even apply a cloud function that contains the logic on how to transform that Firestore data piece entry into a BigQuery table. I'm not going to do that either. I'll use the new query syntax for snapshots. And supposedly more performant. And I don't want to import existing Firestore documents into BigQuery. That will just take too long. But you can do that, and then it will do a backfill. Although I have to say I tried this once and it failed. So existing documents collection. This is if you want to do a backfill from another Firestore collection, if I understand it correctly. Well, that doesn't apply here either. Then we have a collection group query. No, we don't want that, just to avoid any performance issues. Documents per backfill. Yeah, we'll keep it with a default value, but we're not doing a backfill anyway. We're not using a cloud KMS key name, and we also don't need to configure the advanced parameters here. And I'm also not enabling events because I'm not planning to use any of these events for any other processes, or the events that this process emits for any other processes in the Google Cloud Platform. So let's click install. And okay, we have to effectively say no here. Let's try again. So this should take 3 to 5 minutes. So once it's done, you should see a get started button that I forgot to record here, but you can then click on manage, or you see processing. So this seems to work. Let's actually run a script from the Adobe Analytics Component Manager. Let's just reload components from Adobe Analytics. And now we should be seeing logs from this tool. As we go into our cloud logging. So to make sure that we see all the logs for that particular function, for that particular process, we can look for any of these of the entries, and then we'll see that they're all running through a particular cloud function, and we'll copy that and then just filter for those. And we see it's doing something, it's fetching the archive, blah, 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 blah. Then we get this wonderful error again, wrong type of Firestore field for time partitioning, accepts only strings in BigQuery format and Firestore timestamp. But I mean, the document, where is it again? Here we see this started. This is our thing, our source field. It's clearly a timestamp, but the extension doesn't process it properly. Maybe I just didn't understand something here, but that's always the same problem. So it's inserting a row into BigQuery, and it has inserted the row into BigQuery. The extension has completed, and then when the script is done, so 17 seconds later, the script run document was updated by the component manager function. So we have another change to the document, and again this function execution starts. Again we get this error or this warning. I mean, it will just leave the started field empty, but everything else will work. So we see that the script run ID is this one here. This is the document ID that it took to insert into BigQuery. So let's take a look into BigQuery if we really received that field there. So let's go to our script runs, raw changelog. Here on the bottom, we should see this particular document. Yeah, and we see the two entries, the one for create and the one for update. And what we also now see is we can take a look at the script runs raw latest view, which basically exports or queries that script runs raw changelog data. Here we see the query that it does. And it takes the latest document for a particular document ID, and it will just see the latest state. So we should see the same state as we have in Firestore. So let's take a look and let's query. This time we'll query this, select star from where, and what is the name again? The schema document ID equals, let's see if that works. Yes. So here we see the particular document, latest state, and we see the data is all in JSON. Of course, with BigQuery JSON queries, we can create a flat table. So let's take a look at the flat view that I've created here as well. And this is basically what I'm doing here. Looks a bit weird, but in the end we'll get duration seconds, error ID, result running, script name, and sheet ID as the final output. And before that, that's simply transforming the nanosecond timestamp from Firestore to something that BigQuery can work with. And then I can use this table. Let's take a look at the table. I just do a little query. This is what it looks like. Some scripts were never stopped, so they don't have a stopped or completed timestamp. They failed. And here we have the duration. The scripts that failed have a -1. I mean, I was testing a lot in the beginning, so the earliest scripts are always -1. Then we have the ID, the result, the script name, the sheet ID, etc., all nicely extracted from that JSON per document. And now we can go to Looker Studio. And I'm not going to explain to you here how to create a Looker Studio connector to BigQuery. That's pretty basic stuff. And if you don't know that, you'll find billions of tutorials for that. But here I built a mini dashboard, so to say, for all for my client overview, which client is using the component manager the most. So record count is basically entries into the database. How many script runs did they do? Then which script types are the most popular. And then I have just a list of the latest script runs. It's a nice way for me to monitor my client's activity in the component manager. Hope that was helpful. Have a nice rest of the day. Thank you very much.